Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Let's say you need to create a load balancer with a cloud storage bucket as the backend to serve an application within a VPC network. Which of the following options is the preferred approach? Option 1. Create an internal TCP/UDP load balancer and a private service connect NEG as the backend. Option 2. Create an internal HTTPS load balancer and a private service connect NEG as the backend. Option 3. Create an internal TCP/UDP load balancer and a serverless NEG as the backend. Option 4. Create an internal HTTPS load balancer and a serverless NEG as the backend. Option 5. Create a regional external TCP/UDP load balancer and a private Google Access NEG as the backend. Slide 2. Identifying the correct solution. Now that we've reviewed the question and all the options, let's break down the correct answer. The correct choice is the fourth one. Create an internal HTTPS load balancer and a serverless NEG as the backend. This answer is correct because it perfectly pieces together the right components for the job. Let's look at the three key requirements from the question. First, the application is within a VPC network, which means we need an internal load balancer. Second, the backend is a cloud storage bucket, which is a serverless product. The specific tool to point a load balancer to a serverless product is a serverless network endpoint group, or NEG. Finally, serverless products like cloud storage are accessed over HTTP, which is an application layer protocol. This means we need an application-aware, Layer 7 load balancer, which in this case is the internal HTTPS load balancer. To really understand this solution, we need to talk about network endpoint groups, or NEGs. An NEG is simply a group of backend endpoints for a load balancer. The most important type for this question is the serverless NEG. Think of it this way. A normal MIG of virtual machines is like a row of houses on a street. Each one has a fixed address. A serverless NEG is different. It's like a special PO box address for a service that doesn't have a fixed location, like cloud storage or Cloud Run. You send your traffic to this special address, and Google's internal network takes care of routing it to the right serverless service behind the scenes. So, when you want your load balancer to send traffic to a serverless backend like a cloud storage bucket, you can't point it to a list of virtual machines. You have to point it to a serverless NEG, which acts as the official, load balanceable address for that service. Choosing the right load balancer. The next piece of the puzzle is choosing the right type of load balancer. Google Cloud offers many types, but for this problem, the choice is between a Layer 4 and a Layer 7 load balancer. A Layer 4 internal TCP/UDP load balancer is like a simple mail sorter at the post office that only looks at the zip code. It's very fast, but it only understands network protocols like TCP and UDP. It just forwards packets without looking inside them. A Layer 7 internal HTTPS load balancer is like a more advanced mail sorter who can read the entire address, including the recipient's name and apartment number. It understands application protocols like HTTP and HTTPages because a cloud storage bucket serves content via HTTP requests. You need a load balancer that can understand and route that kind of traffic. Therefore, the internal HTTPS load balancer is the correct choice. A Layer 4 load balancer simply wouldn't know what to do with an HTTP request intended for a cloud storage bucket. This diagram shows how all the pieces fit together to create our final solution. Inside our VPC, we have a client, which could be another virtual machine or a user connected via a VPN. This client wants to access the content in our cloud storage bucket. Instead of connecting directly, the client sends its request to the private, internal IP address of our internal HTTPS load balancer. The load balancer's forwarding rule sends this traffic to a backend service. This backend service doesn't point to a group of virtual machines. Instead, it points to our serverless NEG. The serverless NEG is configured to point to our specific cloud storage bucket. It acts as the bridge, allowing the load balancer to send traffic to the serverless Google service. This entire traffic path stays within Google's private network, never touching the public internet, providing a secure and efficient way for internal applications to access data stored in cloud storage. To be sure of our answer, let's look at the other NEG types mentioned in the incorrect options. The first two options mention a private service connect NEG. This is a powerful tool, but it's for a different job. You use a PSC-NEG when you want to connect to a service that is running in a completely different VPC network. It's a way for a service consumer to connect to a service producer across VPC boundaries. In our scenario, cloud storage is a Google-managed service, not a service in another VPC, so this is the wrong tool. The last option mentions a private Google Access NEG. This isn't a real NEG type for load balancing. Private Google Access is a feature you enable on a subnet that allows virtual machines without external IP addresses to make outbound requests to Google's public APIs. It's for traffic originating from your virtual machines, not for load balancing traffic to a service. This makes it completely unsuitable for our problem. Let's walk through the G-Cloud commands needed to build this solution. It's a multi-step process. First, you create the serverless NEG itself with the G-Cloud Compute Network Endpoint Group's create command. The key parameters here are network endpoint type, which is set to serverless, telling Google what kind of NEG it is, and cloud storage bucket, where you provide the name of your bucket. Next, you create a backend service with the G-Cloud Compute Backend Services create command. Here, the important flag is load balancing scheme, which is set to internal managed. This specifies that it's for an internal HTTPS load balancer. Then, you add your NEG to this backend service. Finally, you create the rest of the load balancer components. A URL, mapped to route requests, a target HTTPS proxy, and a forwarding rule. This is the step that actually creates the private IP address for your load balancer inside your VPC. This forwarding rule ties everything together and makes the service available to your internal clients. Thank you for your attendance. Please consider subscribing to the channel.